Hello everyone and welcome to our channel MooTekie. Today we're diving into the world of workshop machinery with a fundamental and powerful tool, the drilling machine. Get ready to learn all about how it works, its different types, and the various operations it can perform. Let's get started. Now let's begin with the basic components of a standard drill machine. On the screen you'll see a clear diagram. At the top, we have the hand wheel rise, which is used for manual control. Below that, the central part is the spindle, which rotates. At the end of the spindle is the chuck, which is the clamp that holds the cutting tool, the drill bit. Below the drill bit, you see the swivel table, where the workpiece is secured. The power comes from the motor virage, which is connected to the spindle via a V-belt to transfer power and change speeds. And the entire assembly is supported by the sturdy pillar or vertical column. This is the core anatomy of a drilling machine. Now let's explore just how important this machine is. The drilling machine is one of the most important machine tools in a workshop. As regards its importance, it is second only to the lathe. Isn't that fascinating? In a drilling machine, holes can be drilled quickly and at low cost. The hole is generated by the rotating edges of a cutting tool known as the drill, which exerts large force on the work clamped on the table. And here's an interesting point. As the machine tool exerts a vertical pressure to originate a hole, it is loosely called a drill press. Drilling machines are made in many types and sizes, each designed to handle a class of work or specific jobs to the best advantage. So it's all about choosing the right tool for the job. So what are these different types? Let's take a look. The common types of drilling machines include the portable drilling machine, which is handheld and mobile. Then we have the sensitive drilling machine rate, which is for light, precise work. There's the upright drilling machine for medium-sized work, and the massive radial drilling machine for large, heavy parts. We also have the gang drilling machine Gapaitions, which has multiple workstations, the multiple spindle drilling machine that can drill many holes at once, the automatic drilling machine for production lines, and finally the deep hole drilling machine Gapaitions, specially designed for, you guessed it, drilling very deep holes. Quite a versatile family, isn't it? Let's understand a couple of these types in more detail, starting with a small but crucial one. First up, the sensitive drilling machine. It's a small machine designed for drilling small holes at high speeds in light jobs. It can be mounted on a bench or the floor. Its construction is straightforward. It consists of a base, a vertical column, a horizontal table, a head that supports the motor and driving mechanism, and finally, a vertical spindle for driving and rotating the drill. Its name, sensitive, comes from the fact that the operator can feel the cutting action, allowing for precise control. Now, for handling slightly larger tasks, we move to the upright drilling machine. This machine is designed for handling medium-sized workpieces. Here's why it's so useful. In an upright drilling machine, a large number of spindle speeds and feeds may be available for drilling different types of work. The table of the machine also has different types of adjustments, giving the operator great flexibility. There are two general classes of the upright drilling machine. The first is the round column section, or pillar drilling machine, and the second is the box column section. Each has its own structural advantages. And when the workpieces get really big and heavy, we need a true powerhouse. This is where the radial drilling machine comes in. It is intended for drilling medium to large and heavy workpieces. Imagine the base of this machine, it's massive. The machine consists of a heavy, round, vertical column mounted on a large base. Now here's the clever part. The column supports a radial arm, which you can see in the diagram, that can be raised and lowered to accommodate workpieces of different heights. This design means you can move the drill to the workpiece, instead of moving the heavy workpiece to the drill. Now that we know the types of machines, what can we actually do with them? The operations that are commonly performed on drilling machines are really diverse. They include 1. Drilling, 2. Reaming, 3. Boring, 4. Counterboring, 5. Countersinking, and 6. Spot facing. Each of these serves a unique and important purpose in machining. Let's break them down. Let's explore the first 3 operations. First, drilling. This is the fundamental operation of making a circular hole by removing a volume of metal from the workpiece by a cutting tool called a drill. It's where every hole begins. Next, reaming. This is the operation of sizing and finishing a hole already made by a drill. Reaming is performed by means of a cutting tool called a reamer, which has several cutting edges. This process makes the hole smoother, straighter, and more accurate in diameter. Reamers can be classified as solid reamer and adjustable reamer. And third, boring. This is the operation of enlarging a hole by means of adjustable cutting tools with only one cutting edge. So if a drilled hole isn't quite the right size or is a bit off-center, a boring tool is employed to correct and enlarge it. Now let's look at the final 3 operations, which are all about finishing the area around the hole. First, counterboring. This is the operation of enlarging the end of a hole, creating a flat-bottomed recess. A common use is for the recess for a countersunk rivet. The tool used is known as a counterbore. Then, countersinking. This is similar, but it involves making a cone-shaped enlargement of the end of a hole. You see this all the time for the recess for a flathead screw so it can sit flush with the surface. And finally, spot facing. This is the operation of removing just enough material to provide a flat surface around a hole. This is done to accommodate the head of a bolt or a nut, ensuring it sits perfectly flat and tight. A spot-facing tool is very nearly similar to the counterbore, but its purpose is specifically for creating that flat-bearing surface. To wrap up our lesson, let's touch on a close relative of the drilling machine, the boring machine. The boring machine is one of the most versatile machine tools. It's used to bore holes in large and heavy parts, think massive components like engine frames, steam engine cylinders or machine housings. Here's the key takeaway. These parts are practically impossible to hold and rotate in an engine lathe or a drilling machine. So the boring machine is the perfect solution for large-scale precision hole making. And that brings us to the end of our journey into drilling machines today. We've covered everything from their basic parts to their many types and the precise operations they perform. This foundational knowledge is key to understanding so much of modern manufacturing. Thank you for learning with us today. We hope you feel inspired to go out and create something amazing. Thank you. See you in the next class.